C.5 hints for another 3 test 1 questions. Question number 16, number 17, and number 19. Yeah. But I like to put number 16 and number 17 together because they have the similar structure. Yeah. They both work on 10-element array. All right, 10-element array. So the problem size equals 10 here. Right. Next, for problem question number 16, we are given one condition, x1 less than x2. But for problem number 17, the condition is x1 greater than x10. Yeah. Then the question, for question number 16, we need to find the maximum number of inversions. And the question number 17, the minimum number of inversions. All right. Because they are so close, so let us talk about the general problem-solving method here. Yeah. All right. Here, I like to talk about one general, general problem-solving method. Yeah. Actually, this method is not new. We use it multiple times in this class. Here, let me just, give you another, chance to use it. All right, so what's that? So the idea is pretty simple. All right, so here we use this kind of special thinking way here. All right. We want to make our problem easier to solve, right? Yeah. Because if you want to work on it directly, it looks like you need to do a lot of work, right? Yes. Because this problem size relatively large. Right? Yeah. When the problem size relatively large, then it is relatively hard. Yeah. So based on that observation or the property, general property, all right, in order to make it easier, one typically used method, reduce the problem size. How about that? Yeah. We just reduce the problem size, but we keep everything else. We do not change everything else. All right? Yeah. So only change one factor, problem size factor. No change on other things. How about that? No change on other things, only problem size. Yeah. Because in this way, we can make it easier, yeah, and we can get some experience. With this experience, hopefully we can extend our solution to the more general case. Yeah. All right. So with this idea, can we change the problem size from 10 to 3? Yeah. Yeah. 3, the minimum. The minimum we want to get, but at the same time meaningful. meaningful case, right? Otherwise, if n equals 2, too trivial, it looks like nothing to work, right? Nothing to work. We need to keep something to work, right? We need to keep something to work. So that's the reason we changed to n equals 3, not 2. Yeah. So here we use the meaningful minimum case. All right. To work on these two questions for n equals 3, that should be very easy, right? Very easy. Yeah. But after you work it out, do you have an idea for the general solution or more general cases? If still not clear, yeah, that's possible. Yeah, only work on one simple case. Still, you cannot see the property, the rule clearly. So then you may like to try n equals 4 to give you more study cases, right? More study cases to get more experience, more observation with that kind of information. As much as you can, then at some point you should be able to get the solution for larger problem sizes. Larger problem sizes. All right? So here I just point out this direction. You need to work it out by yourselves. But this direction you can try. All right? Yeah. So this is general. In many situations like this, you can try this strategy. You can try this strategy. All right? Yeah. Okay. Let us go to question number 19. Yeah. For this question, the problem size n equals 9, and it is an odd number. Yeah. Why I emphasize this odd number? Because the similar question, I already worked it out for you in a video, but that's for the even number case. Yeah. We have that. So we have a video for even number case. I give you a complete solution there. Can you use that solution, modify a little bit for this odd number problem? Yeah. Here I refer you to this video module for part D.4. Yeah. So you go there, you watch that video. That one gives you complete solution, but that is for the even number case. All right. So here you only need to bridge the gap from odd to even. Only need to bridge the gap. All right. Yeah. Let me just give you a little more information. Yeah. So you think about that. Yeah. Suppose we have odd number of elements, x1, x2, ... yeah, x2k minus 1, x2k, and x2k plus 1. Yeah, the last 3 elements. Yeah, and based on the method we used in that video and for the 4 video, remember we grouped them in pairs. The first pair, second pair, and so on. Yeah. The last pair, but we have a singleton left. For even case, there is no singleton, right? For even case, there is no singleton. But for odd case, there is one singleton left. Then we group them in Then we do comparisons based on pairs, right? Yeah, comparison. X1, X2, do one comparison, all right? Yeah, X3, X4, another comparison, and so on. Yeah, the last pair, X2K minus 1, X2K, one comparison, all right? Then the singleton, the last one, singleton, X2K plus 1. All right, we leave there. Yeah, we leave there. You need to do some special management on the last element, singleton element. All right, then look at the next step. All right, yeah, next step. When we do comparisons, we have the minimum, smaller one, and a larger one, right? Yeah. When you do comparison, here you can assume all the elements are distinct. Yeah. In order to make our discussion easier, yeah, we can assume we have distinct elements. Yeah. Don't worry. Yeah. Don't worry. Just make it as easy as possible for our discussion. Yeah. All right, then for each comparison, there is a smaller one and a greater one, right? Can we make this, make that assumption? Because here we just want to get something specific for discussion, right? Make our discussion as easy as possible. But we do not change the nature of the problem, right? We do not need to change the fundamentals of the problem. The fundamentals still there. Yeah. All right. With that, then look at the next step. Look at the next step. When we look at the minimum, do we just look at the top group for minimum, right? For minimum. Not bottom group, right? Because bottom group, we know they have no chance to be the minimum, right? And then the bottom group will try to find a maximum, right? Yeah. Because the top group, there is no chance to be the maximum, right? But here, that is for the even case. Here, how do you handle the singleton? Yeah. Which group you want to make the singleton join? Yeah. The singleton join which of the two groups? Okay? Yeah, think about that. Yeah. So the question, which group do you put x2k plus 1 in? All right? Yeah. But when you look at that question, you just need to ask this question. Is it, yeah, here, I refer to that x2k plus 1, all right? Is it possible to be the minimum? Right? Is it possible to be the minimum? Then the same question, is it possible to be the maximum? Right? So based on the answers of these two questions, you know how to handle that singleton element, right? How to handle that singleton element based on the answers of these two questions. If it's possible to be the minimum, if it is possible to be the maximum. So then you can get the answer. All right, so that is our video 3.5.